Galvanized steel, 0.5 mm thick, is notoriously difficult to weld using a 2.6 mm electrode. The slightest bit too hot can cause the material to immediately perforate. However, in this experiment, I tried the spot welding technique to control the heat and maintain the integrity of the material. Before welding, the joint area was cleaned to stabilize the arc and reduce the risk of porosity due to the galvanized layer burning. For materials this thin, heat control is far more important than welding speed. I used a 2.6 mm diameter E6013 electrode with a fairly low current. The technique used was a short, gradual spot welding. The goal was to allow the material time to cool so that heat wouldn't accumulate in a single spot. Pay attention to your hand rhythm when spot welding. Each spot should have sufficient time between welding. If the rhythm is too fast, heat will build up and the risk of burn-through will increase dramatically. The angle of the electrode also plays a significant role. I maintained a roughly 45-degree angle to the direction of the arc to keep the arc controlled and avoid putting too much pressure on the surface of the thin material. Here, the results were quite interesting. The material didn't burn through, and the joint was successfully fused. However, when viewed by professional standards, the bead still looks less than neat and uniform. This is one of the biggest challenges when using a 2.6 mm electrode on 0.5 mm galvanized steel. For cleaner, more manageable results, many welders prefer 1.6 or 2.0 mm electrodes. Smaller diameters typically produce a smoother bead and allow for easier heat control on thin materials. Do you think these results are successful enough for 0.5 mm galvanized steel?